Hi, I'm Eitan Adar, a faculty member at the University of Michigan. It's my pleasure to describe this joint work with Elsie Lee. The general problem we're tackling today is the lack of conceptual tools by which communicative visualizations can be designed and evaluated. Communicative visualizations are a prevalent type of visualization, and examples range from simple charts in scientific articles to sophisticated interactive examples in online newspapers. The specific problem is one of intent, or even more specifically, that we are failing to account for design intent in design and visualization. Without doing this, we can't know if one design is good, or even if one design is better than the other. Cognitive efficiency frameworks for evaluation can't really help us here. They often imply that if someone decoded the visualization correctly, we should be happy. But clearly this isn't the case. No one intends for their communicative visualizations to go in one ear and out the other. Instead, we argue that the designer wants to have some kind of cognitive impact in the viewer. Our proposal is that communicative visualizations should be viewed from an educational lens. The designer is an instructor and the viewer a student. This has a number of benefits. First, it allows us to describe a wide range of cognitive impacts a design visualization can have. These range from being able to remember something to being able to execute some process. Second, it lets us acknowledge the power differential inherent in communicative visualizations. And finally, the kind of learning objectives we focus on are naturally tied to assessments. A learning objective framework takes the form of viewer will be able to verb noun. Verbs here come from cognitive dimensions like recall and calculate. Nouns are specific to whatever range of information we want the viewer to learn. The amount of unemployment, the performance of our algorithm relative to others, the process for deciding on a course of treatment. And these are not the in-the-moment kinds of objectives that only exist when the visualization is viewed. Viewing communicative visualizations through a learning objective lens lets us argue about the skills and memories that should persist for the viewer. So to summarize the rest of this in terms of learning objectives, let me say that after watching this talk, the viewer will describe how communicative visualizations are like a teacher-student relationship, describe the limitation of current frameworks, apply the objectives framework to critique communicative visualizations, and identify how designers might be able to leverage the learning objectives approach. I don't have time to address all the related work, but I'll point out that many existing task and evaluation taxonomies have really struggled to find work on evaluating communicative visualizations. In a couple of large meta-studies on evaluation on the order of 800 papers, there's barely any mention of communicative visualizations, 4 times in one and 0 in the other. While there are amazingly rich task taxonomies for each sub-area of visualization, networks, trees, text, somehow all communicative visualization gets lumped together. Much of the advice we find on how to design good communicative visualizations borrows broadly from the visualization literature, but these guides rarely find a way to connect to the designer's intent. What's interesting is that we've actually started to apply the strategies of good teaching, things like storytelling or draw your own, to visualization design. What we're suggesting is that learning objectives can help connect the dots between what we want to teach and how we should do it. I'll end with this one last point about communicative theories of visualization. Both the process-focused approaches, things like Shannon and Weaver's model, and the meaning-focused, the semiology-semiotics camp, tell us about how communication happens. Unfortunately, none go so far as to help us model and evaluate intent relative to design. Bertin gets closest by acknowledging that the goal of communicative visualizations is to provide memorizable information, but even that falls short of the breadth of intents. Before we continue, I want to address our choice of language, designer and viewer. Our working assumption is that communicative visualizations, unlike so-called exploratory visualizations, have 2 parties involved. Our designer stands in for any number of people, scientists, journalists, policymakers. The designer here has disproportionate power. While a good designer might use a user-centered approach in defining their intent, this isn't required by our framework. Being able to identify the designer's intent explicitly will help us determine if it matches the viewer's needs. In trying to find a starting point for learning objectives, we looked at a number of frameworks ranging from Bloom to Structure of Observed Learning Outcomes, or SOLO, to the Data Information Knowledge Wisdom, or DIKW framework. I'll point you at our paper if you want to know more about these. But ultimately, what we decided on is what is known as the revised Bloom taxonomy. It's one of the better studied frameworks, with clear assessments, and really supports the kind of language we want. The revised Bloom is basically this grid structure with verbs on one dimension and nouns on the other. It's intended to be hierarchical, with both nouns and verbs getting more complex, but whether that's true or not we'll leave to another talk. The verb dimension has 6 main categories that go from to remember, to understand, to apply, to analyze, and finally to create. Each of these have subcategories and example verbs we can use. So the understand category has subcategories including interpret, exemplify, summarize, infer, and so on. For each verb, we might also have synonyms, so like generalize and abstract. The noun dimension has 4 main categories: factual, conceptual, procedural, and metacognitive. As you'll see in a second, while we use the verbs directly, the nouns are replaced with specific examples. Again, each of these knowledge dimensions has subcategories. For example, we might distinguish terminology and specific details under the factual knowledge category. To create a learning objective, we pick a noun and verb dimension. For example, let's take this example of the Phillips curve, a kind of economic model from The Economist. Here I might say, the viewer will be able to recall that low unemployment is associated with high inflation. Or in this example from Wikipedia's article on the Babesia's life cycle, I might say that the viewer will be able to paraphrase the key stages of the parasite's development. At the layer of analysis, we might have learning objectives that require the integration of a number of lower-level insights. For example, this visualization on architecture and justice may have the objective: viewers will be able to contrast the indicators and identify the disproportionate impact of justice on some communities. At the critique layer, an example might be Jon Snow's ghost map, where the intent might be described as, the viewer will critique the hypothesis that cholera is airborne, or judge as accurate the model of cholera is waterborne. Notice that the nouns we work with don't have to be simple insights or ideas. They can include conceptual knowledge. For example, in this interactive visualization from the Financial Times on climate change, we might intend for the viewer to analyze the impact of different policy bundles on global temperature. Or in this example, from a medical guide for nurses, we might say things like, the viewer will be able to apply an algorithm for making a medical decision in an emergency room. It is also worth saying that many visualizations have multiple objectives. That is, we can have multiple intents when we communicate. In our Phillips curve example, we might also say that we want the viewer to summarize over which time period the correlation between unemployment and inflation vanished. Because of the pseudo-hierarchical nature of the framework, we can also upgrade or downgrade objectives. We can replace a simple "we'll be able to classify" to "we'll be able to generate hypotheses." The designer can dial in the appropriate learning objective. In part, this might be done to accommodate different kinds of viewers. I don't have time to go through all the combinations, but I'll point you at the paper in our website. We used examples from the Siegel and Hare storytelling paper and the Hullman and Diakopoulos rhetoric work. Where we couldn't find an example for the taxonomy in those papers, we added our own. Now, it's probably obvious that some combinations are more or less likely. It's hard to imagine that we intend for one visualization to allow you to create a metacognitive framework of racial biases. Many higher-order objectives likely require many visualizations or even a full textbook. That said, we were still curious if our framework actually mapped to what communicative visualization designers actually did or thought. To test this, we ran a survey with members of the Data Visualization Society. We specifically targeted those who were in the process of building visualizations and were sharing the work in progress. We used these visualizations to create a short 3-question personalized survey where we provided example objectives for the visualization. Respondents could indicate whether any of our given learning objectives were really their intent, but could also add their own. So here's a sample visualization from one of our participants. One objective we suggested was, the viewer will recall that all 5 major pageants have Black title holders in 2019. Here's a heat map reflecting the distribution of the learning objectives in our survey. After sending out 34 surveys, we collected 132 objectives from 29 participants. The distribution of their learning objectives in the taxonomy grid was very similar to ours, but you can see the tendency towards the upper left or more simple intents. 16 of our participants also agreed to a follow-up interview. We talked to each for 30 minutes, trying to understand their design process and their thinking about their specific visualization. I'll point you at the paper for the full story, but we'll point out some highlights here. First, 15 agreed that learning objectives were helpful or useful for their thinking about their designs. One participant said, "In your survey, you were like, what do you want people to take away from this? I hadn't really thought about it." The other thing I wanted people to take away was this insight, so I was like, okay, I'll make that more prominent this time. Our participants also reflected that creating learning objectives was hard, As one participant succinctly put it, I think it's a useful way to think about it, but it's hard as well. This is something that we know is true from the education literature and something we want to explore in the future. Participants also highlighted things that were not really cognitive objectives. They wanted people to feel or engage, and this points to the limitation of the cognitive dimensions. On our site, you can see the start of an affective taxonomy. This framework includes verbs like receives, responds, and behaves, and nouns that focus on opinions, attitudes, and values. We think that this extended taxonomy might help us evaluate visualizations that have clear or hidden affective intents. For business objectives, we'll argue that ideas like engagement aren't really communicative intents. While they might be a proxy for learning, there are better ways to measure learning outcomes. They can also be viewed as side effects and can be measured as things like time on site. Just to wrap up, I'll mention a few areas of ongoing work. First, we think that the learning taxonomy framework is useful for visualization pedagogy. We've used this approach in our classes and anecdotally find that students change their designs once forced to think about the intents. Second, an interesting side effect of defining learning objectives is we can also define a set of things we don't want people to learn. For example, if we're trying to create a politically neutral visualization, we can use anti-learning objectives, the viewer will not, as a way of describing our objectives. Finally, let me briefly mention assessment. We've alluded to the usefulness of learning objectives in creating assessments, and one thing we're currently focused on is how to generate the right way of testing to see if a learning objective is achieved. Thankfully, we have a broad literature to draw on from the education community, which can help us transform objectives into multiple choice and open-ended tests. For example, we might take our objective around unemployment and inflation and ask, in which of the following periods did correlation vanish between unemployment and inflation? A, 1980 to 1990, B, 1991 to 2000, or C, 2001 to 2010? We can ask this question before the viewer sees the visualization to find a baseline, during the viewing to judge readability, and after to judge recall. The goal here is to get an understanding of what's called the program effect. Did the visualization help us achieve the learning objective across the population of viewers? Whether running the actual assessment on real readers is needed is an open question. It's possible that simply thinking about it is sufficient. It's also an open area of research if we can exclusively use multiple choice questions or need to resort to constructed response or open-ended questions, where we might also need to define a rubric. To wrap up, I'll point you again at our paper and website for full details and all our examples. Our website actually lets you play with different framing of objectives to find the best fit. Hopefully I've achieved my learning objective here, and you can now describe how this framework allows us to better understand, build, teach, and evaluate communicative visualizations. Thank you for listening.